All right, all right. Welcome, everybody. We are having a masterclass on CCIP today. I'm Victor Munoz, a developer advocate or DevRel at Metis L2, and we are celebrating a special week, which we are calling CCAP week. Why? Because we had an entire week with activities focused on bringing more awareness about the integration of CCAP on Metis and what kind of things you can do with this amazing technology. And today, to close this amazing week, we have none of the less that Andre from Chainlink Labs. He's a DevRel, a master DevRel, I should say, and he's gonna teach us everything we need to know about CCIP. And as you can see here on the title, we're gonna kind of become Chainlink CCIP field in 30 minutes or less, which is quite amazing. How are you doing today, Andre?
I'm doing fine. I'm really excited to be your guest today. Thank you for asking.
Awesome. So can you tell us about like what is it that we're going to be doing today?
Yeah, sure. So I'm gonna give you a brief intro, like 30 minutes or less intro to Chainlink CCAP, what Chainlink CCAP is, how it works, and most importantly, how you can build on top of it using Chainlink CCAP. And then we're gonna create a minimal staking example contract on and deploy it on Metis Sepolia. And then from the Ethereum Sepolia, we're gonna transfer some tokens and stake directly all in a single transaction on that staking contract with Metis. And then we can even switch back to Metis Sepolia again to withdraw some LP tokens if we have time.
Interesting. So this is one of the main use cases that we can have with CCIP, and we're not gonna be testing it with Ethereum and Metis, right?
Yeah, that is correct.
Awesome. Please go ahead.
Thank you. Thank you, Victor. So, hello, everyone. As being said, just uh, yeah, as being said, my name is Andre. I'm one of the developer relations engineers at Chainlink Labs, and you can find my Twitter and Lens handles over there. I'm still calling it Twitter. I don't know why. I can help myself. So yeah, Andre underscore dev is my handle. If you have any questions afterwards, but feel free to drop them during the live stream as well. I'll try to answer them if I have time. So first of all, before we deep dive into CCAP, I want to remind you what Chainlink is. A Chainlink essentially is a blockchain services platform. If you've been in space in a while, you might remember or get familiar with Chainlink through price feeds. Price feeds is a service which gives you like price data from off-chain world to on-chain smart contracts, and essentially it enabled a lot. Enabled a lot of DeFi use cases back during the DeFi summer. Aave is one of the largest lending and borrowing platforms in DeFi space, and they used Chainlink price feeds from the beginning, for example, etc., etc. A lot of time passed since then, and Chainlink essentially evolved into a blockchain services platform, offering a bunch of services you can see on screen, plus many more to come. And one of the most exciting one is CCAP, which we're going to talk about it today. So CCP stands for Cross-Chain Interoperability Protocol, and there is a reason why Chainlink is actually called Chainlink. That was the whole vision and idea from the beginning, to link all of the chains into one unified network of blockchains, and using CCAP, which is basically just a messaging interface protocol. You can interact with all of these chains, and you can abstract that layer through your dApps for your end users, so they don't even need to care about are they on chain A or chain B or chain C. Like for them, like token is a token no matter on which chain they are. So this is the short agenda for today. So we're going to quickly explain the blockchain interoperability problem. I'm going to show you some interfaces to show you how easy is to work with CCAP. We're going to just scratch about the surface of the CCP architecture, so we can have more time to actually develop a fully end-to-end simplified app using Chainlink CCAP on Metis and Ethereum Sepolia today. So first of all, we need to understand what is the blockchain interoperability problem. And essentially, like interoperability is the ability to exchange information between different systems or networks, even if they are incompatible. For example, if we have a Twitter has like a web interface, a mobile app on iOS, mobile app on Android, has like a bunch of backend services, probably some large databases. And the thing is that all of these independent services need to function correctly, even if they're, for example, incompatible. Even like, I don't know, iOS app is maybe written in Swift, but the backend is written in, I don't know, Java or Go or Rust. I don't know which language they're using, but you get the point. Like they're still able to function as a one functional unit. So I can log in through my iPhone and then tweet something, and I go to a web browser and still see that tweet and interact, etc. That translates to blockchain world to the ability to share information between different chains, and that was before the CCP a main pain point, main issue with the current state of blockchains. So essentially, blockchains are still kind of like isolated islands, even though there's like a bunch of L2 solutions tied to Ethereum L1. Like essentially, they're tied through a smart contract. You know, like you have sequencers providing transactions, roll transactions, and post them to L1 for like validation and verification. Like that's for security reasons. But if you want to transfer tokens or data between different blockchains, you were kind of forced to use bridges. And the problem with bridges is there, in a lot of scenarios, there were centralized, unfortunately, in the past. So exploits happened, and people unfortunately lost some of their tokens, right? And also there is a problem what with non-EVM blockchains and with private blockchains like bank chains and all of that stuff. So with CCIP, you can transfer both tokens and data, uh, um, no matter which chain there is, and that's accomplished using something we call lanes. So lane is a unified pathway between blockchain A and blockchain B. So for example, if I want to transfer something from on a screen blockchain A to blockchain C, I'm going to use lane A to C. And then if I want to reply a message from C to A, I'm going to use a different lane C to A. And the reason why there are so many bidirectional lanes in existence is like for security reasons and also for scalability reasons, because you have like multiple different lanes where data is flowing, so you can scale better. And each blockchain supported by CCP has unique chain selectors. So chain selector is not the same as chain ID. It's actually UN64 value, unique to Chainlink CCP, and it's just a long number which you can grab from our official docs. And when I'm sending message, I essentially interact with the router contract. I'm going to explain that in a minute by calling the CCP send message. And CCP send message accepts two parameters. Sorry, the first one is the message object, and the second one is chain selector. So CCIP will pass that message, will select the lane based on chain selector and pass that message through that lane. So that's essentially what lane is. And as I said, CCIP is basically a universal message interface to build all cross-chain applications, no matter on which chain are they, like EVM chain, non-EVM chain, public chain, private chain, etc. Like we can connect everything through this one interface. That's the whole point of the CCAP like protocol, right? So
Crystal clear so far. Sorry, Andre, to interrupt you there. It's just I wanted to give a message to the people in our audience. Like, if you have any questions and you're watching now, you can paste your comments and questions here on the channel on YouTube or on the live stream on X as well. And we are going to be trying to answer all of your questions with Andre by the end of the workshop, right? Sorry for the interruption, Andre.
yeah,
Let's
yeah.
continue.
Yeah, sure. So yeah, if you have any questions at all, please drop them in the chat. I'll try to answer them. If you have some additional questions or something you remember afterwards, I shared my Twitter or X profile, so and we are like live on stream, so we can always connect there. I'll try to answer. But yeah, if you have any questions, drop them now. Okay, so as I mentioned, there's like three core capabilities of CCAP. Like with traditional bridges, only the transfer of tokens were possible and in not so decentralized way. With CCIP, besides like bridge is just a feature, right? Besides tokens, you can also send arbitrary messaging, and those messages are essentially bytes data. So whatever you can interpret as bytes data, and that's literally anything, can be sent. So you can ABI encode simple string messages, you can ABI encode complex Solidity structs, you can ABI encode function calls, and then just like there is literally ABI encode from Solidity 8.11 version, I think, and you can just on the other side call that function call, etc., etc. So it's really powerful. And the most powerful thing is our so-called programmable token transfers, where you can just combine both sending tokens and data. And today we're going to do exactly like that. We're going to send some tokens we want the state, and as a data field, I'm going to ABI encode on behalf of which address I want to stake those tokens. So when I go back or switch back to, again, Metis Sepolia testnet with that wallet address, I will be able to withdraw some LP tokens, even though I didn't have it. Don't have at all those tokens on Metis Sepolia. I just had some tokens on Ethereum Sepolia. So that's the true power of programmable token transfers. And CCAP is the only bridge/cross-chain solution that offers you programmable token transfers. Use cases, many, like from DeFi space to gaming to NFT, like cross-chain collateral, cross-chain yield optimizations, all kind of new kinds of dApps for RWA space. Like you can create real-world assets, like tokenize whatever you want, and have CCAP as a protocol, as embed into those smart contracts, into those tokens, meaning that you can transfer your real-world assets across any chain. Like you can interact with even non-EVM chains, with bank chains, private chains, whatever, which unlocks much more use cases and potential in general. So this is probably the most important slide for you as a developer. This is a simplified version of the CCP architecture. And essentially, on the left side on the screen, we have end user or dApp sending a message. So we can see that message plus destination chain selector is provided. And as this light blue, in this light blue color, there is something called the router. That's CCP router contract. There is one CCP router contract per CCP supported blockchain. And that router basically handles, as the name says, routing of cross-chain messages, right? So imagine that you're sending a package using, I don't know, UPS or some other messaging or some other post service, and essentially you create the package, like whatever the package is, I don't know what you want to send, and when you label it, you send like from myself to this address, whatever. Like imagine that that's destination chain selector and the package is your message. You give that to the UPS or other post service company. That's the router, and they will handle routing of the message itself. So in the middle of this screen, there is CCAP, which is essentially a black box for now. We can see that message can contain data, tokens, or both. And then after some time, the router on the other side, so again, from the same company, some other post officer will deliver your message to the end receiver, which is again some other dApp or end user, and you don't need to worry about that at all. There is a CCP Explorer page where you can monitor the status of your message in real time. Similarly, how you can monitor the transfer of your package, especially like if you're transferring across seas. So there's literally, it will take days. For example, for a package to arrive, you can you can monitor it, and there is also a unique message ID, which is bytes 32 value. So you can always send that message ID to the receiver, maybe, so they can also as well monitor the status of the cross-chain message itself. Monitoring is cool, like watching it live on the on screen on the Explorer, but can be also useful, and essentially that's the main thing. It's useful for dApps because dApps, especially front ends, can have can leverage that monitoring functionality of cross-chain message out of the box, because they have message ID and all the contracts are just open source and public. So you just listen to a bunch of events, filter by message ID, and there you have it. Like you can monitor it on your side as well. If you want to transfer tokens or data or both, or you can just want to try, Chainlink CCAP, there is Transporter on transporter.io. There is also a test version on for testnets. You can send tokens, data, and or both, as I said. And as you can see now on this animation, this is how you can track the status of live message in real time here through the transporter without the block explorer, because again, you can easily implement that feature just listening for a specific events from CCP smart contracts and filter by message ID. And transporter is really handy, really useful. Like if you ever need to transfer tokens for whatever reason to from chain A to chain B or chain C, whatever you can chain transfers, you can just go to transporter and just like do it from the UI without any coding at all.
So one
However,
question here. Can I interrupt again?
sure.
Uh, it's just that I think you mentioned in a few slides before that Chainlink is the only one that has like programmable tokens transfer.
Yeah,
Is
that's
this
true.
correct?
Yeah, Chainlink CCP is the only cross-chain solution that offers you programmable token transfers, where you can transfer both tokens and data combined in the same message. And it's really powerful because like you can have a use case where you receive some tokens and then based on some condition do something with that data and tokens combined, like staking, for example, or
Like
something.
staking. Okay, so this is all. I just want to emphasize this. This is only possible with Chainlink CCIP.
That is correct. Yes.
Just go ahead.
Cool. So yeah. So how would you develop your dApp that integrate Chainlink CCAP? So as I said, first of all, with Chainlink CCP, to recap, we can transfer tokens, um, send any kind of data, or both. Then CCP sender can be any address, externally on the account, any smart contract. Anyone can send a cross-chain message. It's just the matter of calling the CCP send function on the router contract itself. You can even do it manually from a block explorer. As simple as that. If you're a receiver and you're receiving just tokens, it can literally be any address. Any address at all, tokens will arrive. If you're, however, sending some data alongside tokens or just data, then your smart contract needs to implement CCP receiver.SQL smart contract, which just implements one function, CCP receive. So router will essentially call CCP receive function to deliver you data. And if you don't implement that function, like that transaction will revert. So it's simple as that, and it's for that reason. So let's imagine that we want to send both tokens and data. First of all, before we start with that's the next slide. This is how you can send and receive messages. So on the top left side, there is a source blockchain. I already mentioned there is a CCP send function which accepts destination chain selector UN64 and some kind of message. Message is struct EVM to any message from the client library, and down left we can see EVM to any message. How EVM to any message struct look like? It has receiver, data, token amounts array, fee token, and extra arguments. Receiver is just the address, is the receiver address, right? On EVM chains, that'll be like address, but we can see that it's type of bytes because it's EVM to any. Like if you want to send some cross-chain message to non-EVM blockchain or some other chain, the receiver address format can be different. So that's why it's bytes data type. So essentially, you're just gonna ABI encode the receiver address. If you're sending some data, you're just gonna put it as a data payload. We're gonna see it in a minute how that looks like. If you're sending some tokens, it's essentially an array of EVM token amount struct, which just consists of address of that token and the amount you're sending. Simple as that. For fee token, if you can use Link for paying for fees, and if you have like some premium discounts if you're paying in Link, but you can also pay in native coin. And if you want to pay in native, you're gonna put address 0, and that's useful because you can just then use message.value for paying for fees, and you can charge users if you want to like pay for fees in native. But essentially under the hood, they'll be converted to a wrapped native address of that token of that blockchain, of course. and the fees will essentially be paid in link, because we're just going to swap them to link to pay the node operators, and that's why paying in link is slightly cheaper, because of one step less. And finally, extra arguments. Extra arguments at the moment has only gas limit, but in the future that might change. So there might be like more extra arguments. For example, for some zkVM chains, they might need some other additional flags. So it's advisable to always make extra arguments mutable, and I'm going to show you that in a minute how to do that. At the moment, gas limit means that's the gas that will be used to call the CCP receive function. On the other side, top right part of the picture, here, destination blockchain, there is a CCP receive function that will be called to deliver the data. That means that if you're sending GEMS tokens, gas limit should be set to 0 to save gas. But essentially, you will measure how much gas approximately CCP receive, calling the CCP receive function on the other side will cost, and you're going to put that value there. Maybe you can add a buffer of 10%. The reason for that is like because gas limit is non-refundable. So like if you want to save some money on CCP fees, you'll just measure that. That's another best practice. Default value is 200,000, and you can just leave it as default if you like. On CCP receive side, you're receiving any to EVM message. So difference struct on the left side is EVM to any message. On the right side, any to EVM message, because you're receiving this on EVM chain, for example, from any chain, literally. And in that struct, we can see message ID I mentioned, sort chain selector if you want to validate from which chain you want to receive messages, sender address or in bytes format, so you can revert if you don't want to receive package from particular senders, data payload if you're receiving data, and again EVM token amount, the same array of token and amount you're receiving as part of that message. It can be useful. We're going to leverage that feature because you want to be sure how much of a token you will receive, so you can just stake them, for example, in our case. So now a little bit of code snippets. We're going to quickly go through them so we can have more time to implement the actual staking contract. So this is the basic message receiver. We're importing CCP receiver contract, and there is underscore CCP receive function. And here what I can see is that I'm decoding the sender address, and also from data field, I received some text. So for example, on the other side, we send hello world, and this is how I can get that text. Obviously, besides hello world, you want to receive something more useful. So over here, I'm decoding some string, some name, and some address, for example, if that's my use case. This is what I received from the data payload. Speaking of sending arbitrary data, this is the basic code for sending data. And again, there is just one function, send. Here, we first create EVM to any message struct from the client library, and we're providing receiver address, ABI encode, receiver address 2 byte. Then, as a data payload, we are sending some string, some text, hello world, for example. Token amounts, this syntax with empty EVM token amount array means that we are not send any tokens, so we're just sending data. Extra arguments, empty, this is the default value, so 200K for extra arguments for gas limit, and I'm paying for fee in link. Over there, I can call the get fee function from the router to calculate fee upfront, and I'm just going to approve router to spend that amount of link in fees. So I'm not going to approve the whole thing, just the amount for fees. And finally, from the router client ccp.send, I'm sending that message to the destination chain selector and returning message ID, so I can track the message in real time. Now, if I want to not send just that simple hello world string, but I'm also sending the address and the text, we can see that now I am ABI encoding message.sender and message text. So you can literally ABI encode whatever you want as a data payload. It's really powerful. Now, if I don't want to send data, we can see no data at all, just empty string on the data payload. If I'm sending tokens, I'm gonna just expand this function to create EVM token amount array. And here I'm sending just one token, so token address and some amount over here, and providing the now populated token amounts array. And one additional line is the over down here where we can see that I'm just approving that token to be approving router to spend that amount of token, because router will need to transfer those tokens for me. So router is the one that handles all the traffic. So I need to approve router to spend some tokens from me. This simplified syntax assumes that you transfer tokens to smart contract, but obviously you can just message transfer. You can transfer from tokens here and then approve router, etc. So yeah, all combinations are possible. Now we're gonna talk about extra arguments, and if you don't want to use that default 200K, for example, you're just sending tokens, this is how you can set it to 0. So simple as that, just gas limit set to 0. And also you can combine both data and token transfers and increasing gas limit now to 500K if you want. So this is programmable token transfers. And again, it says maximum amount of gas CCP can consume to execute CCP receive function on other side. I said extra arguments should be mutable or should not be hard-coded. Because in the future there might be new version of extra arguments, and there is a simple helper contract, so you can just encode it like this, because essentially extra arguments are bytes, so you can just pass bytes if you want as extra arguments to your smart contract, instead of like having them hard coded or in storage variable, or however you wanna fix that. But essentially it's a best practice to not have them mutable, or so you can like change or adjust, because you're gonna maybe miss some new cool feature in the future, or for some non-EVM ZK private chain, whatever, it won't work without some feature from extra arguments. So just be aware of that. And yeah, fees can also be paying native coin besides links. So again, we're taking now looking at the fee token, we can see that it's address 0. That means that we are paying for CCP fees in native coin, and extra arguments are again empty quotes. So that means we're using the default 200K. This syntax will actually work with any version of extra arguments, because we'll always use the default version of whatever the version of extra arguments is. So maybe that can be your strategy. Up to you. And yeah, that's pretty much it. After that, you have message ID or source chain transaction, whatever. You just paste that in a Chainlink CCP Explorer, and you can monitor the status of your message live at the Chainlink CCP Explorer. You'll probably spend the most of your time here at the CCP, the Chainlink, monitoring the status of your message. And in general, Explorer is really powerful because you can do a bunch of other stuff here, but more on that later.
So
Yeah.
quick question here.
Yes.
Where can people like check out this material later?
Excellent question. So all of this is available at our docs. So at docs.chain.link/ccap, that's the CCP section of our documentation. Documentation is always up to date. It has all of this explained in greater detail. There's like advanced guides. There's all about advanced topics like best practices, about rate limits, about architecture, about everything. So you should always refer to official docs. docs.chain.link/ccp. All the content is there, plus more.
Awesome. And for the content of this masterclass, where
I
should
can
people go?
share the presentation and the source code, the GitHub URL afterwards with you if you want.
Yes, that would be amazing. I know that people are going to be asking me this after, because some people were not able to join like the live stream, right?
Yeah,
But people are asking about this, so it's very interesting. So thank you so much again.
you're welcome. Yes, and yeah, if you follow me on Twitter, I share a bunch of CCP tips actually. Yeah,
Awesome.
like random CCP tip, and I generally tweet a lot about CCP and guides and whatnot. So you can always just scroll a bit through my profile and you'll find like a bunch of useful URLs there as well. But yeah, in general, docs.chain.link has everything. Like this is the best way to start. So yeah, your transaction, successful transaction will look something like this. So with a bunch of details, which you can just track. You can see that this is the message ID. Sending a cross-chain message is basically two transaction steps. So one transaction on source blockchain, then another transaction on destination blockchain. We can see this is an example of a message transfer from Avalanche Fuji to Polygon Mumbai, and it took like 2 minutes or something. From this address to this address, fees are paid in link, and essentially I send 1 USDC for whatever reason. So also, if there is for some reason the destination transaction failed, maybe gas limit was too low, or you had some kind of condition that caused the transaction to revert, when you connect your wallet here, you will be able to again just send that second transaction again, override the gas limit or whatnot. So as I said, CCP Explorer is really powerful in general. Now, sometimes development on testnets can be slow, because like you don't want to wait 2, 5, 10 minutes for a message to arrive that you can for you to realize that you have a bug or some kind of flaw in your smart contract. You want to develop fast locally, and because of that, we implemented Chainlink Local, which is a Chainlink CCP local simulator. There is also in a docs a section about Chainlink Local, like dedicated section just for Chainlink Local in the docs, and there is also a guide how to test CCP contracts locally in the official docs. So I highly encourage you to check it out. It's extremely fast, in less over 200 milliseconds. The basic example in Foundry is executed. So it supports Foundry, Hardhat, and Remix ID, both fork and non-fork environments. So again, you can simulate everything much faster, and generally people are using Chainlink Local first for development phase before going proceeding with testing on testnets. We also had some masterclasses hosted in the past as well. So if you want to check those, there is this URL, go.chain.link/masterclasses, so you can rewatch them on demand later if you're more interested in that. But I'm going to share the links with you. And yeah, random CCP tips. You can also check those. And we're going to quickly deep dive into the Chainlink architecture. So Chainlink essentially has like level 5 of cross-chain security, because it consists of 3 independent decentralized Oracle networks: committing DON, risk management network, and executing DON, performing different types of computation and tasks throughout the send of a single cross-chain message. So this is how it works. Now this is the black box expanded, right? So again, you're sending tokens and data from the left by interacting with the router contract. So what router contract does? So first of all, it will interact with the on-ramp contract with the on-ramp contract, yes. If you are sending any tokens at all, on-ramp contract will interact with the token pool for that token, and it will either lock it or burn it, depends on the token sending mechanisms. There are 3 token sending mechanisms, depends on the token. Then committing DON will listen for some events, and committing DON will basically batch all of the upcoming cross-chain transactions in a single Merkle tree. And committing DON will wait for a finality tag. So this is one of the crucial security features. You always need to wait for finality. So all the transactions, cross-chain transactions, need to be finalized and on a canonical chain before we proceed with the cross-chain transfer. And depends on the finality, sending of cross-chain transfer will be faster or slower from chain A to chain B. For example, Ethereum itself has two epochs finality time, and like we need to wait for 2 epochs. But for example, on layer 2s, finality is achieved faster, so delivery of cross-chain transfer will be achieved faster. So you can read more about latency and especially finality in the official docs as well. The same thing will be done by risk management network as well. So risk management network will also calculate Merkle tree with all the transaction hashes, upcoming cross-chain transactions. And committing DON there is another contract which is not on this screen called commit store. Committing DON like all the nodes in a committing dawn will reach a consensus on the final root hash, and the transmitter will paste that root hash to the commit store.sl smart contract. Now, all the nodes from the risk management network will compare that that root hash with the root hash they calculated, and then they will vote, right, to be whether the status of the messages, that batch of messages, is cursed or blessed. We want to see blessed all the time. So blessed is good. After we see blessed, that means that the condition, that the transfer of the cross-chain message will continue, and you can see those statuses on the CCP Explorer page. Essentially, if the lane is cursed, then there means something is wrong happened, like there was a chain reorg on a source blockchain or chain reorg on a destination blockchain, or something terrible happened with the blockchain itself. So for the security reasons, there will be a cursed status, and the cross-chain of messages, the transfer of cross-chain messages will be declined, actually. After that, executing Dawn will monitor all of these events, specifically events from the commit store smart contract. And once executing Dawn see the blast status, that's like a green light for executing Dawn to proceed with the interaction with the off-ramp contract, which again, if you're sending tokens, it will interact with token pools on the other side, again, essentially unlocking or minting tokens on other side. And then off-ramp contract will, through the router contract, deliver the data plus tokens to the end receiver. And that's essentially how CCP works. I think that's pretty much it. Yeah, if you think of CCP as an international flight, do you really need to worry about all of this stuff? Well, technically, no. Only if you debug something, then yes. Like when you're flying from, I don't know, from New York to Europe, you just check in your luggage, and there's like a lot of stuff behind the scene uh, that they will perform to luggage, like a lot of security checks. Sometimes they might even open your luggage and leave you a note. For you, you're just gonna grab a coffee, walk to the terminal, take a flight. Then I don't know, like after you pass the passport control and everything, you're just gonna essentially collect your luggage on the other side. And depends whether you're flying from east to west, or from this country to that country, the flight will be shorter or longer. Similarly, depends on the finality tag. A transfer will vary between 2 minutes to 15, 20 minutes. Depends again of the lane we're using, but that's essentially is. If you have again any questions, drop them in the chat. I'm now going to proceed with the example itself. We have roughly 20 minutes, so I'm going to just speed myself up. Okay,
Let's go.
so remix. Yep.
So how many contracts we're going to be checking out today? Three,
Uh,
four
four,
contracts.
four, yeah, but most of them will be extremely simple. Okay, I'm just going to zoom this a bit. So I'm going to start with, first of all, yeah, if you want to develop with Chainlink CCP, you go to docs.chain.link. This is the official docs, and you go to CCP again, and everything is here, like literally everything. Bunch of guides over there, bunch of concepts you can read more, like latency, all that stuff, API references, everything. So this is up-to-date version of all CCP content, and I encourage you to check it out. Also, if you want to develop with Metis, for example, you go to faucet.chain.link /Metis Apolia or whatever, like connect your wallet, and you can grab 25 link and 0.1 Metis. Also, if you want to develop with other blockchains, like there's like a bunch of faucets here that you can just grab tokens and continue. For example, I selected 0.1 Metis and 25 link. If I click continue, even here I can change the receiver addresses, so I can send to different receivers. And if you're for bot protections for some faucets, you will need to authorize with GitHub essentially, but yeah, which I just did. And I can just click get tokens, and tokens will arrive. This is on, you can even follow transaction hashes over here, and essentially I'll be able to try to start building with CCP. While we're waiting for this to complete, I already have some Metis link and native Metis, so I can continue. So this is the interface of our simplified staking. So just stake and unstake functions, simple as that. Nothing major here. So let's take a look at the staking protocol. So again, do not use this in production. This is a simplified version, but essentially what I'm going to provide is I'm going to provide the staking token address and LP token address. So for staking, I'm going to use CCP BNM. That's a dummy token contract that you can use on all CCP, on all chains. It's provided by Chainlink, and essentially you can just mint it endlessly. So you can always have at least that token to transfer around, to not worry about faucets and everything. So it's really easy to get that token, and I'm going to use it as a like staking token. And as an LP, I'm going to just develop my LP token, which essentially is going to be this simple ERC20 token, which I can just mint as an owner. That's going to be our dummy LP token, right? So I'm going to stake CCP BNM, and in return as an LP token, I'm gonna use this and get this my LP token. So simplified staking essentially has a stake and unstake function. So stake will lock CCP BNM tokens inside this contract and updates the stakes mapping value, and LP token will be transferred in return. When you want to unstake tokens, again, LP token in, staking token, CCP BNM token out, updating, mapping, and that's it. And this is only for owner. It can withdraw LP tokens because essentially as initial liquidity, we're just going to mint some amount of tokens to this smart contract directly. Now, how can we connect this with CCP? Well, I implemented this cross-chain receiver, which essentially inherits CCP receiver contract. And as we said, inside the CCP receive function, when you're receiving data, you're doing something, whatever you want with it. Since I'm using programmable token transfers, I'm going to receive tokens first, and then I want to do something with those tokens. So essentially over here, we can see it's just a constructor, nothing fancy. And inside CCP receive function, I'm doing something like this. So first of all, I will receive some tokens. So from destination token amounts array, from the message itself, I'm going to approve the simplified staking, the staking contract itself, to spend some amount of my tokens, the amount I receive. Because after that, I'm going to call the stake function on the staking contract itself, and I'm staking this amount of tokens on behalf of this address. Like I'm not like the actual receiver is the my address, not this cross-chain receiver contract. And if you go back to the simplified staking, when I call the stake, we can see that safe transfer from of stake token will be called like that function. And because of that, I need to call the approve function here first. And that's pretty much it. So I'm going to deploy staking, LP token, and receiver on Metis Sepolia. And then on Ethereum Sepolia, I'm going to deploy sender, which essentially is the sender contract, which has a bunch of code, but just one function essentially. So that function is again is the one from one of the slides. So forming the EVM token amount array, forming an EVM message, so receiver on behalf of this is the data payload I need for staking on the other side. Gas limit, I'm gonna provide it manually, and here if I'm paying in link for fee token, I'm gonna use link. If not, I'm gonna use native, and this is just enum, which says 0 for native, 1 for link. That's it. And based on the fee token, I'm going to calculate fee. And if I'm paying in link, then I'm going to approve link for spending, and I'm going to transfer CCP BNM inside this smart contract, approve router to spend it later, and just call the CCP send function. And here I'm not approving link because if I'm paying in native, then just transfer the CCP BNM in, approve router, CCP send, and this is the syntax if you're paying in native, so you just need to provide as message.value fees. Here, finally, emitting some events, and that's it. All of these are just two helper functions which will allow you to withdraw a link or native coins I send for fees, and that's it. So essentially, this smart contract has just one sender smart contract. send function. So, okay, let's now compile all of that. So first of all, we're gonna deploy LP token because I'll need LP token. I'm gonna connect to Metis. Metis, I already have some senders, so we'll see. Maybe I'll just use the same sender because gas fees on Ethereum Sepolia are like ridiculously high. So we can see that I have now 0.2 Metis, so 0.1 and 0.1 I had previously. So 59902 I'm on Metis Sepolia, and I'm gonna deploy my LP token. We can see that I already did that test. So if we don't have time, I can maybe just use those, but I will repeat the process. So first of all, LP token deploy. You cannot see that now, but my MetaMask pop up. I'm hitting confirm, and I confirm my transaction. So I'm just waiting for a transaction to be included in the next block, which just happened. This is my LP token, essentially. So simple ERC20, we can see my LP token. I can maybe zoom this part as well. Okay, cool. Now I'm gonna deploy simplified staking, right? So sorry for, okay, zoom out, zoom in. So simplified staking, if you go to the constructor, need CCP BNM address and LP token address. So for LP token, I'm just gonna grab this one because I already have it. So this is my LP token. For staking token address, that's CCP BNM. So I'm gonna grab it from the official docs. So again, everything's in the docs. So if you go to, and yeah, for resources, there's Chainlink Local, the simulator. But I'm gonna go to supported networks, to testnet, and over here, I'm going to look for Metis Sepolia. So we're here, Metis Sepolia. Because I'm going to interact with the Ethereum Sepolia, I'm going to expand this tab and I can see the address of CCAP BNM. So this is my token I'm going to use for staking. So I'm going to just grab the address of CCAP BNM, paste it here, and hit transact. Again, MetaMask pop up. I'm hitting confirm and deploying this smart contract to Metis Sepolia. We're just going to wait for it. Yeah, here it is. So we have simplified staking. Now I can even stake and unstake from here. You know, like I can totally do that. But if I want to allow cross chain, like to allow users from different chains to also use my staking protocol, I will need finally this cross chain receiver to be deployed. And as I said, just will receive tokens and data and literally call the stake function like right here. And let's deploy finally cross-chain receiver. So for cross-chain receiver, it needs simplified staking address. So I'm going to just provide the address of a staking contract, right? And paste it here. And we'll need the address of a CCP router. Why? Because from that address, we are going to receive the message. That address will call the CCP receive. And we can see the CCP receiver needs CCP router address. That means that if any other address call the CCP receive function for malicious reasons, the transaction will actually revert. So we want only to interact with the router contract. And where to find the router contract? Well, again, on the docs. So I'll collapse this. I'm on Sepolia. So router address of Metis Sepolia is right over here. So I'm going to just copy that router address and paste it here and hit transact. I will need to now remember the address of a cross-chain receiver because that address will essentially be the receiver of the message on the other side. So what I'm going to do is I'm going to copy the address over here so I don't forget it. And I'm also gonna pin all of these three contracts. Pinning is cool feature in Remix because that means that once I switch back to Ethereum Sepolia, if I switch to Ethereum Sepolia and once I switch back to Metis Sepolia, I will have all of these three instances as I have these three ones as well from my initial test. So what I'm going to do now is I'm just gonna deploy the sender. And now I'm opening my MetaMask. I'm switching to Sepolia. You cannot see my MetaMask, but you can see that chain ID changed. So now I'm on Ethereum Sepolia, and we can see that now there is no like simplified staking, receiver, and all those contracts because they're on Metis. So over here, there is a cross-chain sender I already deployed. And as I said, like gas fees on Sepolia are ridiculously high. So I'm just gonna, in the interest of time, reuse this sender smart contract. So I'm not gonna redeploy it again. So what I'm going to do is I'm just gonna fund it with some link for fees. Or maybe I have enough link for fees. I'm gonna just fund it once again. And we're just gonna proceed with the sending of a message, right? So to fund, I'm gonna open my MetaMask. You cannot see this, but I'm essentially sending a link to this token address. So link, hit continue, and essentially I'm funding now my cross-chain sender with link. I'm gonna figure it out how to, at some point, I think, how to share my MetaMask pop-ups, but because I think for security reasons, I cannot share it, but it's there, trust me. And after this transaction is completed, if we take a look closely at the implementation of this smart contract, of this function, we can see that I will call the transfer from function of the CCP BNM. That means that I will need to approve cross-chain sender to spend some of my CCP BNM. And how to do that? Well, again, docs. Go to official documentation. Now I need the address of CCP BNM token on Sepolia, which means that I'm going to go to Ethereum Sepolia, find the Ethereum Sepolia Metis Sepolia lane, and this is the address of CCP BNM. So over here, this is just a simple smart contract. I'm going to call the approve function. First of all, I'm going to connect using MetaMask. So the spender is this sender contract, right? So I'm going to paste it here, and the amount, let's do 0.5. Why? First of all, where to get these CCP BNMs? I forgot to that part. So over here, there is all the way down acquire test token page. So I'm going to go there, and we can see that I can mint CCP BNM, just called mint one CCP BNM token. Let's see how much I have. I have enough, but let's do another. So I'm going to mint one CCP BNM, MetaMask pop-up, and it will mint one CCP BNM for myself. So I have like one CCP BNM, and I'm going to send 0.5. So like a half of those tokens, I'll send to Metis to stake inside that simplified staking smart contract. And that transaction completed. So let's say I have one. I want a 0.5. So because it has 18 decimals, I'll need 5 and 17 zeros. That's like 0.5, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. So that's 0.5, 5 and 17 zeros. So I'm gonna approve spender to spend 0.5. And I can now see a MetaMask pop-up that I'm approving 0.5. Unfortunately, you can't see that. I'm sorry. That's just for, yeah.
We trust you, no worries.
Yeah, but essentially, if you open this transaction, you can see that I'm interacting with this smart contract, and now it's confirmed transaction. Hopefully, Etherscan will index it soon. But essentially, here it is. I approved. We can see I approved 0.5 CCP BNMs to be spent by a sender. So how to send the message? Assuming I perform all the steps correctly, I'm going to go back to the docs, to testnet page, and I need to provide the destination chain selector. So I'm sending my message to Metis Sepolia. So this is the chain ID of Metis Sepolia, right? So if I go over here and find the Metis Sepolia lane, there is destination chain selector over here, right? So I'm going to just grab it, paste it here. Or if I just open the Metis Sepolia page itself, I can find the same chain selector over here. So it's essentially the same value. You see, the same value, 377, whatever. Receiver, that's the cross-chain receiver smart contract. So I'm gonna grab this address. I'm gonna paste it here. On behalf of, I'm gonna stake for myself. So I'm gonna just grab my wallet address from my MetaMask. The amount I want to send is 0.5. So there'll be 5 and 17 zeros. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. For fees, I'm gonna pay in link because I send link. And again, pay fees in is an enum. So 0 is native, 1 is link. So I'm gonna paste 1 link. And for gas limit, I can use the default 200K. And I'm gonna hit transact. MetaMask pop up, so you cannot see this, but I'm hitting confirm. And once this transaction is included, we'll see it's pending still. I'm gonna grab the transaction hash or message ID. I can do both. Okay, cool. So it's here. I can even see it on Etherscan, for example. So I'm going to grab this transaction hash and I'm going to go to CCP Explorer. This is the example of a successful transaction, for example. So 0.5 CCP BNM, I sent exactly the same thing earlier. So that's what we're going to see. But if I open CCP Explorer, this is the front page. So I can paste this transaction hash, hit enter, and we can see that the transaction is still in progress. We're waiting for finality on Ethereum Sepolia. That's why it'll take for a bit longer because we need to wait for 2 epochs on Ethereum Sepolia. But we can see how much time have passed and estimated total and all the other details. And also, if I go back, you can also grab, without the transaction hash, you can grab the message ID itself. So I'm just gonna expand this transaction, decoded output. Where is it? Where is the transaction? The message ID. The same thing, basically. Message sent. This should be message ID, but we should also find it from here somewhere. Doesn't matter. But if what I want to say is that if you don't want, you can also paste the message ID, and we're gonna see the same thing. This is the exactly same thing. Obviously, we can see so transaction has 6868 BC45. BC45, that's the same thing. For me, it's much easier to just paste the transaction hash because I just have it, transaction hash, copy, paste, and I'll see it. But if you want, you can expand message ID like this and paste it. So essentially, we're now waiting for finality for this transaction to complete. Once is completed and we see something like this, it'll be a successful page, like successful token transfer. What I can do then is I can open my MetaMask from Sepolia, switch back to Metis Sepolia, right? And I'll find my pinned tokens, so receiver, simplified staking, whatever. And from over here, I can try to unstake some amount of tokens I stake or see my stake or whatever. Like that'll be the final step. But since we have 2 minutes left, I'm going to try answering some questions if you have. And essentially, once we see a success page, that will conclude our workshop for today. So I'm just going to now sit back, relax, and track the status of my cross-chain message in real time. And if you have any questions, I'll try to answer them. So that'll be it. And here we can see that you can join us at SmartCon at the end of this month. So if you wanna join us for, that's the annual Chainlink Labs conference held in Hong Kong today, this year, sorry. So there will be 2 days of main event at SmartCon, and 2 days prior to the main event, we will also have like Hacker House. So this is event specifically crafted for developers, and you can even get Chainlink Fundamentals and Blockchain Fundamentals certificate there. So on the day 1 of Hacker House, you're gonna listen for some classes and master classes and workshops, and on day 2, you will pass the actual exam in person in Hong Kong and hopefully get those 2 certificates. So that's pretty much it. If you have any final questions, drop them in a chat, and I'll pass the mic to Victor.
Thank you so much, Andre. That was a real masterclass. You know, there are other masterclass that are not really masterclass, but this was a real masterclass on CCIP. So congratulations to you and the entire Chainlink team for preparing this very high quality material. I'm gonna be checking this out like in the future, time after time. I know that people are asking me on the M's about this same. So probably we will have to share like the GitHub, the link to the GitHub repo in the future. And right now, I don't see any questions on the main channel. So that means that was pretty clear. We have over 500 people watching this right now. So shout out to you for learning like about this cutting edge technology. And Andre, before we close this space, I have two quick questions. The first one,
Sure.
are you going to be at the SmartCon so that people can reach out to you personally? That's one. And the second one, if I'm a new developer and I just watched this video and I'm like starting my journey with Web3 development, but I really want to leverage this, what exactly should I do or should I build?
Yeah, good questions. So first, I won't be in SmartCon, unfortunately. There will be some other developer relations engineers from our team. And secondly, yeah, that's an actual question. That's a great question. So speaking of URLs, if I go to Twitter, I'm just gonna go to my page and I'll try to find it. Should be somewhere here. Media, just give me 30 seconds, please. Yeah, it's over here. So I'll send you this tweet. So let me grab if I can grab it. So copy link over here. So I basically have all of these URLs here. So this is how you can master CCP and add it to your resume. So starting with transporter, the link to the testnet transporter, I said, link to the docs, link to some previous tutorials and all of those previous masterclasses. So 20 steps, 20 examples, finally concluding with these 15 questions where you can test your knowledge about CCAP. That's the first thing. The URL I'm missing is CLL. Yeah, this bootcamp I'm gonna share. So we after that tweet we also hosted this CCAP bootcamp, which basically has the pretty much the same thing. Like if you go to homework, you'll find these 15 questions, but essentially it's a summary of this tweet. So if you find this tweet, that's pretty much it. That's how you can master it. But before you master CCAP, some knowledge of Solidity is good to have. So I encourage you to learn some Solidity, some details about at least blockchains you will interact with, like Metis, or if that's Ethereum or whatever chains. So you familiarize yourself with those, so you know what to expect in terms of latency, finality, and all that stuff. But yeah, this tweet and some basic knowledge of Ethereum should help you master CCAP. And basically, the trick to master is just code a lot, practice, practice, practice. Take your time, just go through all these exercises. Don't just read the docs, don't just read the examples. Try to do it by yourself. Sometimes you'll see a failed transaction, why it failed, then oh, I forgot something, then repeat the process, etc. That's the only way to master any actually topic. In my experience, like I'm a huge believer of 10,000 hours rule. So if you spend 10,000 hours mastering something, you'll essentially be a master. So yeah, that's it. But yeah, I hope that answered your question. I'm sorry that I won't be in Hong Kong this year, but in maybe next year for any other events, we might see each other.
For sure. Thank you so much. Like, I'm gonna ask you later on the link to this post that you created. Thank you so much for creating
Sure.
like all of these resources for the community. And well, thank you for the masterclass for sure, and thank you for to all the people that joined us today. This is the end of the CCAP week on Metis, but next week, early next week, we're gonna have an incredible announcement for developers. So if you're watching this right now and you're learning this, know that you're on a very privileged position for what's coming and you're gonna like it. So stay tuned to that. Follow the Metis Devs account, follow Metis on social media as well. And if you have any questions, you know where to reach me on social media. I go by the name of Quantic, and also you can reach out easily to Andre as well. So once again, thank you, Andre, and I hope we can repeat something like this in the future.
Sure. Thank you for inviting me. It was my pleasure and it was really fun. Thank you and see you soon.
See you soon. Bye bye.
Bye, guys.